I am Dr. D. Madhavi. There you have learned to store your data using variable names. So each piece of data is stored under a variable name. And the purview of your programming extends as you progress in programming stage by stage. And do you really want to store all the data, every piece of data, as a separate variable name? So it accounts to a huge bundle of data. So it is for you, this data structures course is designed for. So there are different data structures which help you to group and organize data and access them efficiently using the methods or operations associated with the data structure. So in this course, we are going to learn more about data and in detail about different data structures and their operations and how to use them effectively on your use cases. What does a computer do? Fundamentally, computer performs computations very accurately and quickly, a billion calculations per second, and it also remembers results, and it is capable of storing so much of information, that is hundreds of gigabytes of storage. And what kind of calculation it performs? So whatever the programmer feeds, it performs that calculation, and it makes use of a programming language in order to act as an interface between the machine and the developer. And computers only know what you tell them. You are the trainer who trains all these things. And coming to the types of knowledge, broadly they are categorized into declarative knowledge and imperative knowledge. Declarative knowledge is nothing but a statement of fact. Sun rises in the east is a declarative fact. Similarly, imperative knowledge, how to do actually, what is the step-by-step procedure for performing something. Say for making tea, what is the recipe? So how to do things will be indicated by imperative knowledge, and the facts are declared by the declarative knowledge. Here is a numerical example. The first one is the square root of a number x is y, such that y multiplied by y gives you x. So this is finding square root of a given number. So if it is a square root, then that is a fact. Its behavior is such: y into y is equal to x. And imperative knowledge tells you how to arrive at that. So the second bullet point, if you can see, it is the recipe for deducing the square root of a number x. Okay, what is the first step? It is a step-by-step process how to do, right? So the first step is you start with a guess. The guess can be some g. And if g star g is close enough to x, then stop. and say G is the answer. Else, make a new guess and by averaging G and X by G, using the new guess, repeat the process until the close enough. So until you find the right answer, you repeat the same process till you find out the square root of the given number. So this is the how to procedure, the recipe for deducing the square root of a number. And the first bullet point tells you that it is a declarative knowledge. So if it is a square root, then what is its behavior? That is the fact. It is showing the fact. So this is about types of knowledge. And what is a recipe? A recipe is nothing but sequence of simple steps and flow of control process which specifies when each step is executed. And it tells you a means of determining when to stop an algorithm. Computers are machines. And how to capture a recipe in a mechanical process. So it is again two varieties. First is the fixed program computer and the second one is a stored program computer. A fixed program computer is nothing but your calculator and you cannot deviate much in a calculator, just making use of the built-in functions. Whereas in stored program computer, you can devise your own program, write a set of instructions so that the computer can carry out them and fulfill the task. So in stored program computer, the machine stores and executes instructions. And this is the basic computer architecture. It is proposed by von Neumann. That is John von Neumann architecture. He is the scientist who proposed this architecture. So here you find the input device and input is collected from this device and given to the central processing unit. This entire thing is central processing unit and here all the processing and computations will be done and the result will be again given to a output device so that like monitor so that the developer or user can see the result. So here in the central processing unit, you have a control unit and you have an arithmetic logic unit and you have an internal memory unit. And if necessary, you can also connect some auxiliary memory devices to this memory unit. They are called as secondary storage devices. So with calculator, there is of no use, much use. So we focus on stored computer program. So sequence of instructions are stored inside the computer in the memory unit. And these sequence of instructions are nothing but they are built from predefined set of primitive instructions. And they are categorized as arithmetic and logic, simple testing, moving data. Moving data means transferring from input device to memory, memory to output device, or output can be visualized by the user. And there is a special program called interpreter which executes each instruction in order, one by one. After completing one instruction, the next instruction will be stored in the instruction register and so on. So when the cycle is completed, that is when all the instructions in the given program is executed, then the program stops or halts. So how to create these recipes? How to write a program? So a programming language provides a set of primitive operations, and the syntax is defined by the programming language. We have to study the syntax of the operations and make use of the operations as required per our use case. And expressions are complex but legal combinations of primitives in a programming language. So expression is the bigger one. So many variables put together with some operations is termed as an expression. So expression is a complex one, but it is a legal combination of primitives in a programming language. Expressions and computations have values and meanings. They are having a special semantic understanding in a programming language. And the other aspects of languages is primitive constructs. Like in an English language, you have different words to form a sentence. Like, what is your name? Or just take a printout of these files. So we know how to speak in English. Similarly, for system also, it requires a programming language, and the syntax will be defined by the programming language, and it can manipulate the numbers, strings with simple operators. So this is the cloud tag of all the English words like that, to, was, it, okay, which makes sense to the English sentence. So here, this is also a cloud tag consisting of all the keywords, float, bool, these are data types, int, and these are the operators, asterisk, right shift, left shift, less than, greater than, minus, plus, division, equal to, comparatively equal to. So these are the building blocks of a programming language, programming constructs.